And with that, I'll give it up to Joe. All right, well, thanks, Jamey. Well, it's great to be here. And after 9 long years of waiting, it's especially great to be arriving at Pluto finally. So my team is called the downlink data team. And downlink data is all about getting all the raw data back from the spacecraft 3 billion miles away and doing what we do with it on the ground. And there's a lot of stuff we do. We assemble it into images, we make data files for the scientists, we calibrate them, and we archive them. We even archive them for long term so that scientists more than 100 years or more can look at this in the future. So when I'm not doing all this stuff, I like to do one of my favorite things, which is skydiving. Anybody here ever made a jump? Wow, quite a few of you. It's fun, isn't it? Well, and I was asked recently, what does skydiving have in common with this mission? And I'm like, wow, that's a really interesting question. So we made a movie, and here it is, so check it out. Hi, I'm Joe Peterson. I'm the Science Operations Downlink Lead for the New Horizons mission to Pluto. And I'm here to take part in one of my favorite hobbies, that's jumping out of airplanes. You might think that after the thrill of jumping out of airplanes, that getting back to behind a computer and doing basically geeky stuff for a space mission might be not as exciting, but it's not true at all. Working on this project has an immense amount of excitement. We're exploring space. It's pretty amazing. So one of the great things about skydiving is all the teamwork involved. With New Horizons, teamwork is so important. We have many, many people in this project, and unless they all work together as a team, this mission just can't come together. One of the things we do just for fun in skydiving are jumps that are a little out of the ordinary. We take a hula hoop and we actually take turns diving through the hoop. On New Horizons, there's a similar thing going on, that we need to thread the needle. As we go by Pluto, we want to go by just where we want to be, and we want to be the right place to take the best observations. And we have a navigation team that is doing this needle threading that is so hard. It requires precision flying, and we're coming up on the culmination of all this effort, all this planning. Very soon, we're going to go by Pluto and get the actual goods of what this whole mission is wanting to do, is discover this amazing place that we haven't explored yet. Quite naturally, the public believes skydiving is incredibly risky, but those risks can be mitigated. Space exploration is a risky business, and there's a lot of time and a lot of heart and soul involved. In New Horizons, we've got 7 different instruments all taking data of different parts of Pluto, the atmosphere, of the surface. All the timing is so critical and has to be choreographed so well, and that's one thing that our science team has been working on for years. So after a great skydive, you throw out your pilot chute, your canopy opens over your head, and everything gets quiet. You no longer have that wind noise, and now you're just floating, looking at the mountains and flying your parachute down, thinking, wow, what a great job we just did. In New Horizons, that's the same kind of feeling that I think we're all going to feel after we've passed by Pluto, taken our observations, seen them come down, at least seen a good number of them come down, and saying, wow, we really got some great pictures, some great data. So thanks, that was a really fun video to make, and I want to thank my fellow skydivers for wearing cameras on their heads and giving us some of that cool footage so we could get our point across. So when Alan was up, he gave you a bit of a quiz, and I have a few questions for you as well. So shout them out if you think you know. First one is, how are these two similar? Anybody have any idea? Fast, I hear the word fast. Absolutely. Not only just fast, but fastest is the key word here. The cheetah is the fastest animal on Earth. It can run 75 miles per hour. And New Horizons is the fastest spacecraft that's ever left the Earth, leaving at 36,000 miles per hour. That's even hard for me to imagine. Okay, so next question. Similar question, but how are these two similar to you? And the answer is not that New Horizons can make phone calls. All right, so the answer we're looking, a lot of good answers I'm hearing. The answer we're looking for is the memory on board. They have about the same amount of memory. So 8 gigabytes, a lot of you probably have phones with 8 gigabytes of memory. And you know that it's not, you put a bunch of apps on it, a bunch of music, a bunch of pictures, it fills it up pretty quickly. So the key point here is that the New Horizons teams had to work really hard to be careful what we put in memory. Okay, last question, I promise you. So how long do you think it takes commands to get up to the spacecraft and then also come back, for data to come back down from the spacecraft? Any guesses?
5 hours.
I heard 5 hours, which is very close. It's four and a half hours. So 4.5 hours one way means it's a 9-hour round trip. So if we were to send a command to the spacecraft, we'd have to wait 9 hours to see what happened. So controlling this spacecraft with a joystick is pretty much out of the question. So back to the data for a second. So the raw data we get from the spacecraft is not very usable at all. It's a bunch of packets of binary ones and zeros. The scientists can't use it. Nobody wants to deal with that. And that's the whole reason for what my team does, is we had to come up with a way to automatically produce data that's usable by the scientists from this kind of randomized collection of stuff that comes back. And we call that the science data pipeline. So it looks kind of complicated here, but I can explain just the basics of it. So on the left side, we have packets. These little pink boxes are packets. And we pull those multiple times a day from our Mission Operations Center in Maryland. And we put them in our database here in Boulder, Colorado. We pull them over the internet. And then what we want to do is go back and look in that database for all the packets that make up a particular image or data file we're trying to produce. And then put them together in the right order, produce that data file, and then calibrate the data. So we produce 2 files, one uncalibrated, one calibrated, then we put it into the archive. And that's what our pipeline does. So you might imagine that this took some testing, a lot of testing actually. So here's New Horizons before launch, of course. It's in a clean room. And how can you tell it's in a clean room? Bunny suits, yes. So the bunny suits are there, of course, because we want to keep New Horizons clean, and people are really dusty. Okay, so one of the instruments on New Horizons is called LORRI. We've talked about that one before. It's the high-resolution camera that we're going to get a lot of great data back from. And that was one of the first instruments I was able to test with the pipeline. And it was very exciting because we hadn't tested any real data on it yet. And LORRI team said, hey, we have some packets for you. I said, give them to me. We'll put them together. So I had the pipeline crunch on those packets, make the image, and then the image popped up on the screen. And it wasn't at all what I expected. I expected some blurry image from inside the, I didn't expect anything from space, but I expected a blurry image from inside the clean room, something like that. But no, it was an image, plain black background image with the word hi. I picked up the phone, I called the LORRI team and I said, I'm not sure, but I think your instrument just said hi to me. Should I be concerned? Is it self-aware? What's going on here? And they said, no, that's just a test pattern we use. It's exactly what you want to see. I said, oh, good, that's what I see. So how do we collect this data? Well, as has been talked about before, there's a team that actually makes the plan. They plan everything ahead of time, all the maneuvers. And what you're looking at is a very sped up computer-generated animation of the Pluto encounter. And right now you can see depicting a scanning of Pluto, taking images of the various parts of the system. And as you see, we're getting closer to Pluto. So we're going to take the really high resolution stuff. Now we go over to Sharon, take some of that, back to Pluto. And just as we pass by Pluto right now, we turn and look back toward the Earth and the Sun, right through Pluto's atmosphere. And as Fran said, we have special instruments that are going to collect the data from that and actually let scientists figure out what that atmosphere is made of. It's pretty cool. And of course, as we leave the Pluto system, we'll be capturing some more scans. So that's what the encounter looks like in fast motion. Okay, so this next one is a detail, and this shows you as you get really close, the high-resolution images, Pluto doesn't even fit. We have to take a slew of images in these stripes, kind of like the panorama function on your cell phone, your camera, where you actually have to stitch the images back together. And that's exactly what we're going to do to get the highest resolution image of Pluto back on Earth and put it back together. So speaking of these great images, Alan and the project really wanted to make this available to all of you. And we put up a site, and you can get to it. There's the address right there. So I encourage you to go to the site. It has relatively raw images, so you see the images just like we first see them, before we've done anything with them. And new images are coming down every day. Well, not every day, but a lot of days. And it takes about 2 days before you'll see the images that just have just come down. But we hope you go to this page and you follow along with this as we encounter Pluto for the very first time. Well, thanks. And I'm going to turn it back to Alan for some final words.
Great. Well, that was great, Joe. And I want to tell you there are a lot of ways to follow New Horizons.